Alright, for number 15, we would ask ourselves, can we use the chain rule? And here we cannot use the chain rule yet because we do not have everything raised to the same power. So since we don't have everything raised to the same power, then we're going to first think about what's happening in between these two different functions, and they're being multiplied together. So we will use the product rule. So that's the first, as is, times the derivative of the second function. And we do have to use the chain rule because we have all of those terms raised to the same power. So we're going to say that's 2 out front, write the inside as is, reduce the power by 1, and then multiply by the inside of that function. Plus, it's going to be now the second function, as is, times the derivative of the first function, so that's times, and once again we have a group of terms raised to the power of 3, so we're going to use the chain rule. We're going to move the 3 to the front, multiply it times the front, write the inside function as is, reduce the power by 1, and then we're going to multiply by the derivative of that inside function. So here we use the chain rule, and here we also use the chain rule. Okay, so it's the first times the derivative of the second plus the second times the derivative of the first. And I'm going to clean up a little bit here. I'm going to bring the singles out to the front, so that would be 2, and it doesn't matter the order of the groups. And then for the second term, I'm going to look for the singles. We have a 2 and a 3, so I'm going to write this as 6. And then I'm going to write down the groups, and once again, it does not matter the order of the groups. And that's it. All right. For number 16, first thing we're going to do is we're going to rewrite the function by taking the square root of that group, and we're going to rewrite it as that group raised to the 1/2 power. So we have a fraction which says that we should use the quotient rule. So it's going to be the denominator, as is, times the derivative of the numerator, which would be 1, minus the numerator. So I'm looking for the derivative of the denominator. Of course, we have a group of terms raised to a power. So that's the chain rule. Okay, so we're going to multiply by the power. We're going to bring that power 1/2 out to the front. We're going to write the inside function as is, reduce the power by 1. 1/2 minus 1 would be -1/2. And then we're going to multiply by the derivative of the inside. So that would be 3x squared plus 0, or just 3x squared. And of course the quotient rule says we don't stop there. We divide that by the denominator, and then we're going to square it. Okay, let's clean it up a little bit here. So in my first term, we have these two multiplied together, so that times 1 doesn't change anything, so that's x cubed plus 2 to the 1/2 power, minus, and I have a couple of singles. We have minus x, we have a 1/2, and then I have a 3x squared. So I'm going to go ahead and bring all of that out to the front. Multiplying 1/2 times 3, we get 3/2. X times x squared, that's x cubed. And then, let's see, we got the singles all together, yes, and we're going to write the group behind that. So x cubed plus 2 raised to the -1/2 power. And then this says that when we square this, Of course, we're going to multiply these exponents together. 1/2 squared, of course, is just 1, so we're just going to take all of this and raise it to the power of 1, which is just x cubed plus 2. And this would be the simplified version of that derivative.